theorem. Suppose f of x is equal to a constant. Then I claim that the integral from a to b of f of x dx is just c times b minus a. And we are going to prove this two different ways. Proof. The integral from a to b of f of x dx is equal to the integral from a to b of c dx. And the integral of c is cx. And we evaluate it from a to b. Well, plugging in b, we get cb minus plugging in a to x, we get ca, and then we factor out the c, and we get the results that we want. Proof 1. Now, proof 2. What does the integral of c dx from a to b mean? Well, it's the area under the curve of the function from a to b. Okay, a to b. Now, the function is always c. So between a and b, there's the function. And we want the area under that curve from a to b. It's a rectangle. The height is c. The base is b minus a. So its area is c times b minus a. Proof number 2. So you don't always have to use integration to do these things. Okay, since it's just a constant, you can draw it. If it was a line from a to b, and you want to know this area, well, that's and you know the height, because you're told maybe what f of x is, so the height is going to be f of b. Okay, so you have the height, because you compute f of b, and you know f of a, you know f of a, you know f of b. I take back that I want to call that the height. You have f of a, you have f of b, they're parallel, and this is our trapezoid. So it's going to, the formula for the trapezoid, or for the area of the trapezoid, is base 1 plus base 2, which we know, over 2 times the height, and the height is just b minus a. So we could compute this. In fact, it's gonna be f of b1, sorry, f of b, one height, plus the other height, which is f of a, over 2 times, I should have said one side plus the other side, the average of the two parallel lines, f of b plus f of a, divided by 2 times b minus a. That's exactly what you would get if you found the equation of this line and you integrated it from a to b. You don't always have to use calculus. That finishes this